make this concept even simpler by comparing a distributed system to something we are all familiar with: teamwork. Imagine that you are organizing a huge college festival, and there is no way one person can manage everything, right? So setting up the stage, managing the budget, coordinating with vendors, and handling logistics. So what do you do? Now that we have explored basically the example of teamwork, let's define what a distributed system is in a technical term. So a distributed system is essentially a collection of independent computers, often referred basically as nodes that work together to achieve a common goal. Alright, now let's dive into two key performances factor of distributed system: latency and bandwidth. These two concepts are essential to understand how data moves through a distributed system and how efficiently the system is. Hi there everyone, welcome to Prep Train, the channel where we simplify complex topics and help you build expertise in backend engineering and technology. I am Sai Kumar and I am super excited to have you here today. If you are new to Prep Train, let me give you a quick introduction. This channel is all about learning, growth, and practical knowledge. Whether you are diving into distributed system, exploring API design, or tackling advanced coding challenges, we are here to guide you on every step of the way. Now, let me set the stage for today's topic, which is distributed system. Think about it like, how does a platform like Netflix handle basically million of users streaming at the same time, or how does an online marketplace like Amazon basically ensures that your shopping cart syncs perfectly across devices? The answer basically lies in distributed system, which powers some of the most reliable and scalable platforms that we use daily. Understanding distributed system isn't just for expert. It is a skill that can level up your career and help you design better system and basically make you stand out in an interviews. So don't worry, we are here to break everything down step by step. So whether you are just starting out or brushing up your skills, there is something that we have here for you. Before we jump in, make sure to subscribe to Preptrain YouTube channel and turn on notifications so that you don't miss any of our future videos. Trust me, we have got some fantastic content coming all your way, and your support basically means the world to us. Also, don't forget to join our 15 Telegram community for exclusive job and internship opportunities, as well as the latest tech insights and news. The link will be in the bio of this channel. Alright, let me just grab my deck and then we will dive deeper into basically the fascinating world of distributed system. Stay tuned. Alright, welcome everyone. Let's kick things off by diving into a concept that's absolutely critical in today's tech world: distributed system. Now imagine this: you are watching your favorite show on Netflix, or texting your friend on Instagram, and maybe even checking your files on Google Drive, all at the same time. So ever wondered that how these apps basically manage to run smoothly even with millions of other people doing the same thing? The magic is behind all of this is what we call distributed systems. So what exactly is a distributed system? So in simple terms, it's a group of computers, often referred to as nodes, working together to appear as a single system. Each computer or node in this system might be located somewhere different, sometimes even in different countries. Yet all these, collaborate seamlessly to process the data, handle traffic, and ensure that the system operates efficiently. Now let's look at some real world examples. So let's say Netflix basically uses distributed system to stream high quality content videos to million of users simultaneously. Instagram basically ensures that your feed is updated in real time while serving content to users all over the globe. Google Drive also allows you to access your files from multiple devices even if one server basically goes down. Now that we have basically covered the basics of what distributed system is, let's move on to the next slide where we'll be simplifying this concept with a real world example of teamwork. Alright, let's make this concept even simpler by comparing a distributed system to something we are all familiar with: teamwork. Imagine that you are organizing a huge college festival, and there is no way one person can manage everything, right? So setting up the stage, managing the budget, coordinating with vendors, and handling logistics. So what do? You basically form a team. So each person in the team is responsible for a specific task. One person can handle the budget, another can take care of logistics, someone else can work with basically vendors, and so on. So what happens if one person gets sick or can't complete the task? The rest of the team can basically step in to make sure that the event can still happen, right? The work does not stop because just one person is unavailable. This is exactly how a distributed system works. Instead of relying on one powerful computer to handle everything, tasks are basically divided among multiple computers or nodes, and these nodes basically work together, and if one node fails, other can take over and ensure that the system keeps running smoothly. This is why distributed systems are so powerful, that basically they provide both efficiency and reliability. Each node, like a team member, has a specific job to do, and just like a well organized team, they coordinate basically to get the job done faster and effectively. Now that we have connected the concept of distributed system to teamwork, let's dive deeper into the technical definition of a distributed system on the next slide. Now that we have explored basically the example of teamwork, let's define what a distributed system is in a technical term. So a distributed system is essentially a collection of independent computers, often referred basically as nodes that work together to achieve a common goal. These computers can be located in the same room, in different part of a building, or even across the globe. So what makes this system basically so powerful is that to the user, it appears as if they are interacting with a single unified system. Let me give you an example. Imagine that you are uploading a file to Google Drive. You don't see the complex network of servers handling your request, right? So you can just drag and drop the file. It seamlessly uploads, and behind the scene basically the file is likely being processed by multiple server, possibly in different location, which are all working together to store and manage your data. So from your perspective, it's just like one single system, but in reality, it's many systems which are actually collaborating. Now let's talk about two major benefits of distributed system. So first of all, fault tolerance. So if one node fails or crashes, the rest of the system basically keeps running smoothly. This is crucial for services like, let's say, Netflix or Instagram, where downtime can result in huge loss. A single point of failure is basically avoided since other nodes can take over if a failure will be happening. Secondly, scalability. As your platform grows and more users come online, you can easily scale by adding more nodes. This ensures that your system can handle the increased load without slowing down or crashing. It's like adding more lanes to a highway to, accommodate more traffic. Now that we have covered what a distributed system is and its benefit, let's move on to the next slide where we will discuss two important factors that impact the performance of a distributed system: latency and bandwidth. Alright, now let's dive into two key performances factor of distributed system: latency and bandwidth. These two concepts are essential to understand how data moves through a distributed system and how efficiently the system basically performs. Let's start with latency. Latency basically refers to the time it takes for data to travel from one node to another. Think of it like sending a letter. If you are mailing a letter to someone in the same city, it will arrive much faster than if you are sending it across the country or even across the world. So in this context of distributed system, latency is basically the delay between sending a request and receiving a response. Ideally, we want low latency, which means data moves quickly between node and user basically get faster responses. For example, when you are refreshing your Instagram feed, you don't want to wait a long time for the new post to load, right? The lower the latency, the quicker the data moves and the better is the user experience. Next, let's talk about bandwidth. Bandwidth basically refers to the amount of data that can be transferred between nodes at any given time. So imagine it like a water pipe. So basically, the wider the pipe, the more the water can flow through at once. Similarly, in distributed system, the higher the bandwidth, the more data can flow between nodes without causing bottlenecks. So low bandwidth is like trying to push a lot of water through a narrow pipe. It slows everything down, and even if the latency is low, if the bandwidth is restricted, the system can still experience, slow down, because not enough data can pass through all of them at once. Both latency and bandwidth basically impact the overall performances of a distributed system, and it is important to design a system that minimize latency and maximize bandwidth to ensure that data moves both fast and efficiently between the nodes. Now that we have covered the impact of latency and bandwidth on distributed system, let's move on to the next slide where we will explore how consensus algorithms basically plays a critical role in keeping these systems in sync. Next, let's talk about consensus algorithm, which are crucial for maintaining consistency in distributed system. So what exactly is a consensus algorithm? In a distributed system, you have multiple nodes working together, often in different locations. These nodes need to agree to reach consensus on the current state of data to avoid confusion. For example, if you update your Instagram bio, all the server needs to agree on your new bio so that every time you log in, you see the correct information across all devices. Without consensus, some nodes might show, one version of your data while the others show a different version. This could lead to all sorts of issues like conflicting date or incomplete updates. That is why consensus algorithms are very critical. They ensure that all nodes in the system are basically agreeing on the same set of data, even when some nodes basically fail or give incorrect information. So two of the most popular algorithms that are used in distributed system are Paxos and Raft. So let's break them down. So Paxos is algorithm is basically one of the earliest and most well-known consensus algorithm, and it is designed to maintain consistency even in the face of failure or delay. Paxos basically ensures that even if some nodes crash or basically deliver incorrect information, the system as a whole will still reach the correct consensus. If we talk about Raft algorithm, Raft is basically a newer consensus algorithm that is often used in modern distributed system. So Raft is basically designed to be more understandable or easier to implement than Paxos while still providing the same high level of consistency and fault tolerance. Now that we have covered how consensus algorithms basically help nodes to agree on the state of system, let's move on to some real world use case scenarios of distributed system in the next slide. Alright, let's wrap things up by looking at some real world use cases where distributed systems are applied. You might be surprised to see how common they are in the technology we use every day. So first of all, cloud services like Google Drive or Dropbox. So when you basically applied a file to Google Drive or Dropbox, that file isn't stored on just one computer. Instead, it is stored across multiple servers, ensuring that your file is always available, even if one server goes down. This is a classic example of a distributed system in action. By distributing your data across various nodes, these services ensure basically that fault tolerance and scalability, and you can access your files anytime from anywhere, even if there is a failure in one part of the system. Secondly, streaming services like YouTube or Netflix. So when you basically stream a movie or video from Netflix or YouTube, the content isn't coming from a single server. Instead, it is distributed across multiple servers worldwide to ensure that you get the fastest and smoothest experience possible. These services are user distributed systems, so to handle the massive amount of data that needs to be streamed to millions of users simultaneously. By distributing the load across different nodes, Netflix and YouTube can ensure that your movie basically keeps playing without buffering, even when millions of others are watching that movie at the same time. So if you talk about social media, let's say Facebook or Instagram, so every time you post a photo or update your status on Facebook or Instagram, a distributed system is at the work, making sure that your data is stored, processed, and displayed to your friends and followers. These platforms rely heavily on distributed system to keep your feed updated in real time while supporting millions of users across the globe. Now that we have explored some real world examples, you should have a clear understanding of how distributed systems are used in everyday applications. Let's move on to the next slide where we can summarize basically everything that we have learned so far. Alright, we have covered a lot of ground so far, and let's take a moment to summarize the key points about distributed system. At its core, a distributed system is a collection of independent computers or nodes working together to perform a unified task. These systems are designed to handle large amount of data traffic and basically processes all while appearing as a single system to the end user. The goal is to achieve scalability, fault tolerance, and improve performance. Let's break this down into the main points that we have discussed. So first of all, like say multiple computers are working together as one system. So a distributed system basically relies on multiple computers or nodes that collaborate to process data and run tasks. Each node is independent, but together they form a network that perform as if it were one system. This is how large scale applications like Netflix or Google Drive can handle millions of users all at once. And the user only sees the front end interface, but behind the scene, all these nodes are working hard to ensure that the system runs smoothly. They are also used in popular services like Netflix and Instagram and Google Drive. We have seen how distributed systems basically are the backbone of some of the most commonly used applications today, whether it's streaming a movie or Netflix, basically refreshing your Instagram feed or uploading files to Google Drive. All of these things we discussed today, right? So distributed system basically ensure that these services remain available, reliable, and fast. The key benefits also we discussed, so scalability and fault tolerance. So two of the most important benefits of distributed system are scalability and fault tolerance. So scalability means that you can easily add more nodes to the system to handle more traffic or data without causing issues. This is crucial for growing applications that need to support increasing number of users. Fault tolerance ensures that even if one node crashes or fails, the system as a whole continues to operate. This means that users won't experience any downtime or service interruption even when something goes wrong on the backend. We then talked about challenges, let's say latency, bandwidth, and consensus. So these systems have their challenges. Latency is the time that it takes for data to travel between the nodes, and bandwidth is how much data can be basically transferred at once. These are the two key factors that can impact system performance. Additionally, consensus algorithms are necessary to ensure that all the nodes agree on the current state of the system, even in the face of failures or discrepancies. Thank you so much for sticking around until the end of this video. Today we covered the foundation of distributed system, explored real world use cases like Netflix and Amazon, and discussed how this system basically enable scalability, reliability, and efficiency in modern technology. I hope that you found the explanations crystal clear and the example relatable. If you enjoyed this video and learned something new, don't forget to give it a thumbs up. It really helps us to reach more learners like you. And if you haven't already, make sure to subscribe to Prep Train and turn on notifications, so that way you will stay updated on the latest videos and never miss out any valuable insight into backend engineering or distributed system. Your support basically makes a huge difference and allows us to keep creating more in-depth practical content just for you. Also, I would love to invite you to join our 15 Telegram community. It's the perfect place to stay updated on the latest job and internship opportunities and get career tips and connect with like-minded learners. The link is in the description of this video. You can find it out and don't miss out. Once again, thank you for being part of the Peptane community, and more exciting videos on distributed system and backend engineering are coming soon. Until next time, keep learning, keep building, and I will see you in some other video. Take care.